everyone. Welcome to the Blooms and Beyond podcast, a podcast that uncovers plant history, culture, and management through the lens of science. I'm your host, Ping. How's everyone doing today? As a plant person, I admit that I enjoy plants more than just about anything in the whole world. But let's be honest, the life of an ornamental plant isn't just all sunshine and chlorophyll. Just like as human, they've got plenty of obstacles to face before they can show off their beauty. And one of the biggest challenging or troublemaker are pests. Yes, the uninvited party crackers of the plant world. So today's star pests really know how to make their entrance, the red-headed flea beetles. Now, don't let the name fool you. It isn't funky rock band like the Beatles or a quirky superhero. They are tiny, hoppy, and leaf-chewing menace that puts plants through the ultimate makeover challenge. The results of those, except the results aren't really pretty. And a lot of growers know them well, maybe a little bit too well. So in today's episode, we got Dr. Shimat Joseph, an entomologist, to chat about the flea beetles, what they like, and how to spot them out, what makes their beauty joyous, and more importantly, some of the ways to manage them. So grab your magnifying glasses, maybe a cup of coffee, and get ready because we're going to hop into the world of red-headed flea beetles. I don't want to steal any more thunder from our speaker today, so let's jump right into it. Without further ado, here is my conversation with Dr. Shimat Joseph. I hope you enjoy it. Hello, Dr. Shimat Joseph. Welcome to the podcast. First of all, let's start off with the introduction. Can you tell us, the audience, a little bit about who you are and what you do?
Sure. So my name is Shimat Joseph, and I am an associate professor in Department of Entomology, University of Georgia. Mm-hmm. So I work with insect problems in turf and ornamentals. Since I have ornamentals, I work in nurseries and a landscape system where the pests are a big problem, So in nurseries, I work with a variety of insects, pests, but the main one that I focus at this moment is red-headed flea beetles. This beetle was brought to my attention when I started the job here. And what I realized is that very less work been done on this pest. Mm-hmm. The work, when I mean that the research that the growers need to manage this pest.
Yeah, so can you tell us about what first sparked your interest in horticulture or in the pest, and how did this come into your radar in the first place?
Well, I did my bachelor's in agriculture. Mm-hmm. So I had opportunity to see all different disciplines in agriculture. That includes entomology.
Oh, yeah.
So I kind of, over the years, it's a 4-year degree program. And towards third or fourth year, I started developing interest in horticulture, also entomology. The two areas that I liked. And entomology, for sure, I liked it. The most.
So what about you? How long have you been here at the UGA as a entomologist for ornamentals?
So I started in 2017. Mm-hmm. So it's about 8 years now.
Okay.
So I'm with UGA.
Okay. Yeah. Now let's move more into the pest. And can you tell us a little bit about the pest and what does it look like and how do they behave out there in the ornamental world?
Right. I will just start with this name. Mm-hmm. It's called red-headed flea beetle. Yeah. So there's three components, I would say. One is their red. Mm-hmm. So they have a red tinge in their head, in the forehead area. Yeah. And that's what we call it red. It's a red tint. So that's what the redness come into play in the name. It's a flea beetle. Yeah. So flea beetles usually have a elongated or kind of stronger leg, I would say hind leg, a rear leg. And that leg is basically allowing them to jump. Okay. And that's what the jumping behavior, that's what they call it, flea beetles. Mm-hmm. And they're a beetle. Oh, yeah. So beetles, basically they're chewing mouthpart. they feed and munch on the plant leaf tissue. So this is came to my attention when I started the job, when I visited the nurseries, where growers just showed me this damage, and they already know. So when I asked them, and they basically listed this is number one problem for them that they are dealing with for years, and they need solution to it. So this pest is like a beetle, and it feeds on the plants. And it's basically, in this particular beetle, they feeds on the surface of the leaf, and they basically rasp the leaves. They basically gnaw it. And in that process, they remove the cells and tissue on the leaf.
Okay.
And with time, what happens is that the area that they fed becomes sunken and disintegrates and becomes holes. And if they feed multiple times, it becomes like a short hole. So you'll see the leaf kind of a lot of short holes on the leaves. And that is basically appears like a skeletonization, because you see the leaves as a veins and other areas, right? They start feeding on the bit areas between the veins. And if there are a lot of feeding going on, the leaf look like skeletonized. Only the veins remain. And with time, that leaf will fall. So in nursery world, this is not acceptable, right?
Yeah.
Because they had to sell the crop.
Especially in ornamental.
Correct.
Yeah.
Yeah, everything needs to be clean as much as possible to sell it. So that is the challenge here. So these beetles feeds on that as adults. When they mate and they start going into the soil. In this case, it is a container with a growing medium in there.
Yeah.
So we have pine bark as a main. That's what predominantly growers here use. And start laying eggs. And the eggs hatch with whatever time, depending on temperature. And the larvae just start feeding on the roots. So they start feeding on the roots, and they go through about 3 weeks like that. And they mold into a stage called pupae. That's basically resting phase. Again, that's happening in the pot itself, in the soil, the growing media of the container. And after like a couple of weeks, they emerge out as adults, mate, and the cycle continues.
So for anyone who's listening who does not know anything about entomology, or as a layperson, how do you tell them, like, what does this pest look like? How do you tell them apart? And this is the insect, this is not. So can you tell our audience and how you tell this pest apart from other normal pests, like ants or cockroach? Like people would know, because we already covered the redhead part. But what about the main common characteristics that a layman or not a pest people would know?
That's a good question. So yes, they are beetles. So beetles have a hard exoskeleton, meaning hard covering. So insects are unlike us. They have an outer shell. And they are segmented. Right? So insects, you're right. They have 3 pairs of legs. And in this case, they have a pair of antenna and 2 pairs of wings, right? And the first pair of wings is basically hardened, and they use that for protection of the body. And that's basically in the back. And they have the second pair that is more filamentous. And when they're in flight, they open up the front or forewing up, and the hind wing, the wing that is beneath that, just expands and they fly. That's how the beetles are. And all the beetles, unlike other hemipterans or other bugs that you're talking about, like they have a straw-like mouthparts, and some has a rasping type mouthpart, and you might have seen lapping mouthpart with honeybees, and so all the different is involved in how they habit and where they feed and things like that. For beetles, they have chewing mouthpart. So we call it biting and chewing mouthpart.
Kind of like the mosquitoes, or they have the...
No, mosquito has a straw-like mouthpart. Right? So their the mouthparts are kind of developed into a straw, and inside we have needles. So in mosquito, in this case, we have 6 needles in there. So when they do that, they basically insert these needles. We call it stylets. That's what we call it. And they arrange this of 6 needles such a way that they can inject saliva into the system. Could be a plant, or it could be fetuses, the sour tissue. And they already digest it and suck it up.
Okay.
Yeah.
Okay.
So they're basically munching it. They are basically eating the tissue as such into their body.
Okay.
And that's how they're feeding it. So they have mandibles that's used for crushing it. They crush the tissue and they basically ingest everything rather than digesting it pre-orally or anything like that.
Okay, so for the flea beetle, they have like 3 pair of legs and 1 pair of antenna, and the main difference is that they have a hard shape.
Hard shell.
That can protect them from...
That is true for all the beetles.
Yeah.
This is all true for all the beetles. Yes.
Yeah. Now, back to the red-headed flea beetle specific, what kind of plants that they like the best, the most, and are they chewing like flowers or newly leaves or any like specific parts of the plant?
Yes, that's a very good question. Red-headed flea beetles, has evolved the way that they can handle the chemicals in the plant and the phytochemicals, and they can tackle multiple plants in different families. So we know that they can feed over 50 plant species, and that comes in different families. Okay, so that kind of shows how versatile they are and their ability to tackle the toxins that's present in the plant, the phytotoxins. So these insects are polyphagous in that way. We call it polyphagous, poly meaning many. So they can eat many plants. And that's one reason this is a dangerous pest in our ornamental system, because when you go to nursery, you have all different plants and different families. And they have a capability to go and attack any plant that is present and still complete their life cycle. Right?
Yeah.
That's why they are seen as a most kind of serious problem in nurseries. Yeah.
Okay, so can you give us some examples of the plant that they are feeding on and causing damage? Like I know, like you guys have done work on hydrangea perliculata, so I assume that's one of the major. I don't know if it's a major host plant or just a normal host plant, but can you give us a little bit more like examples of what kind of plants that do those pests?
Yeah, you're very right. Panicled hydrangea, that is paniculata. Hydrangea paniculata is one of the main one.
Okay.
Because we grow a lot of that now, and it's a main crop for a grower. So if you go to any wholesale or any retail nurseries, this is a very wanted kind of plant now. So it is a high demand. So that is a major crop. In addition to panicled hydrangea, they go after weigelias, forsythias, hollies, different kinds of hollies.
Okay.
But we see majority in Japanese hollies a lot. Iteas, sweet spear, Virginia sweet spear, we want to call it. So there are many plants like that. But we see only this problem in container nurseries though. So we did some work in the past where we were kind of wondering where they're coming from. So in that time, there was a notion that they're coming from the landscape surrounding the nursery, and they're flying in, starts feeding on the weeds that grow on the edges or the field, and they gradually come into the field, kind of an invasion kind of scenario. But we did our work, and based on our work, what we feel now is that's not true entirely. Maybe it's happening to an extent, but it's not truly the major driver. It's the major driver is the nursery itself. They are in the nursery. And what we learned is that they like this environment that we provide as in a container. So container itself is well drained and water is not stagnant there. It moves very fast. And that environment that we provide is their favorite environment. And that's what they like to stay and grow. That's why we don't see them when we did our samples in the landscapes, we didn't see them at all there. So, and we haven't heard red-headed flea beetle as a problem in the landscapes too. So we are more toward kind of thinking at the point is this is a problem, it's a nursery problem, considered a nursery problem, and not in the landscape.
Just because you guys believe that the red-headed flea beetle likes the container environment more than the landscape. So back to your point, where does the plant come from? Do you think it's already rested in the container itself or in the soil? Okay, so you think it's in the soil?
So this is a native species. So we believe that it's present in North America.
Okay.
And they like water it is not dry conditions, they won't do well.
Okay.
So the larvae has to be in the soil.
Okay.
So we know that they need a little bit wet conditions. And if you look at some of the crops that we grow, for example, cranberries, cranberries in the north, they grow in more wet, marshy conditions.
Yeah.
And they like that of conditions. At the same time, they don't want like swamp conditions. They want to do well too.
Okay.
The level of drainness and at the same time, a moisture retention is needed for them to be successful.
Okay.
And I think the containers in the nurseries are providing exactly that. And they just love it. And they just stay there and continue their population.
So you think that the red-headed flea beetles are already in the container nursery somewhere and resting, and until the container production system installed and have their favorable environment, which is kind of like a wet condition, and they start to thrive and then become a problem
maybe originating from a field situation somewhere and got into the nursery in the beginning with. And as we do the trade and nursery production, we move plant materials from nursery to nursery, region to region. In that process, maybe they got spread everywhere.
Okay.
And they're basically using that as a niche, their niche habitat right now.
Okay.
And thriving there.
Yeah. So you kind of briefly mentioned the life cycle of this pest, and they go through, they have the larval stage and the pupa in the soil, and then they become adult. Do you have the second instar, or just like other pests? Or like, can you give us a more like a brief introduction of its life cycle? What kind of conditions, and then how long does the life cycle for the pest?
So it starts off with adults laying eggs, and they happen to be laying eggs inside the soil. So they can lay on the surface all the way down to like 10 centimeters deep.
Oh, okay.
Can go that deep. So eggs are laid there. Now eggs will hatch into the first instars, the first instar larvae. And the way things work is that insects grow inside the shell.
Okay, yeah.
And it's not like gradual like us.
Yeah.
We are continuously growing, right?
No,
Well, insects cannot do that. So they are growing inside. And when they get to a certain size, they shed the skin. They call it occlusion, or not occlusion, the molting. That's the word we use.
Okay.
So they molt, basically they lose that old skin and they make their own new skin.
Oh,
In that process, they increase the size. Right?
Okay.
So we call it first instar, like first stage, whatever that is. And they molt into another stage, a little bigger. We call it like a second stage. So we call it the second instar in this case.
Okay.
So we don't know exactly how many instars these beetles are undergoing, but we think that is about 3 instars.
Okay.
So they go through 3 times like that, becoming bigger in size as they grow. So 3 stages of development. Then when they get to a point where this is a holometabolous, that means these insects need to break down into something totally different. They look like as an adult.
Yeah.
It doesn't look same, right? So larvae is now very resembling the adults.
It's kind of like how the butterfly.
Correct.
The whole process of the butterfly.
Exactly.
Yeah.
Exactly. It's just like a butterfly and the monarch butterfly you might have seen in the butterfly gardens.
Yeah.
Same idea. So larvae, they are in the root habitat. That's where their habitat is. And they go to a stage when they're done with that, they completely go into a resting phase. As to resting, meaning they're not eating. That point, they are just reconfigurating in there, changing into something else, they're changing into something different. So they are doing that breakdown in a stage called pupal stage.
Yeah.
And after that, they molt into a beetle. They come out as a beetle. They're totally different from the larval stage.
Yeah.
Right? And that's why it's called holometabolous. They're completely changing. It's not like same. Okay. So adults comes out. And they sneak out from the soil and they come out and they want to eat something. They'll eat. They try to find a mate. They're to mate. And all this process takes like 6 days, about 6 days. We don't know exactly how many days they take to mate, or we don't know all those details yet. But what we know is that within that time frame, they start feeding and also start mating. And once that is done, they are ready to lay eggs. So that process again starts. So their entire life cycle, that stage from egg to all the way to adult, it takes about 1 month in a summer day.
Okay.
In a summer temperature. We are talking about 80, 85 degrees Fahrenheit. That's kind of temperature. But if it is cooler, it takes longer.
Okay.
So it's all temperature bond.
Okay.
How these things work.
But here in Georgia, I would say, so do you think it's just about 1 month, or at least southeastern part of the U.S. would be about 1 month to complete their whole life cycle?
Yeah, it can practically do it in 1 month.
Okay. So, again, with the complete change phase, it's kind of like a caterpillar to butterfly. They look exactly, well, not exactly, totally different from the instar to the adults, right?
Correct.
So you kind of briefly mentioned that they also cause damage to the root ball. So those would be the instars, right? Because when they become adults, they were out there, not in the surface of the soil, but out there looking for pests to chew on, right?
Correct. I mentioned that larval stage is feeding on roots. The one thing, remember that we don't have any evidence of root feeding damage.
Okay.
They might be feeding the roots, but out in a nursery setting, we are looking at roots, and we didn't see anything so far. So as a larval stage, when they feed on the roots, we don't have any economic damage to report.
Yeah, no.
Anything to report, we don't care, really, because that's not impacting the sellability of the crop.
People only see the plant itself, not the root yet.
Right.
Yeah.
But as an adult, they are destructive because that's a destructive stage, economically important stage of that pest. Adults feed and they cause damage and doesn't care whether it is a freshly new leaves are coming out or is old leaf. They can feed on both alike.
Oh, so they can feed on all the leaves. Doesn't really matter if it's newly leaves or older leaves.
Correct.
But they don't damage the flowers yet, right?
Well, they can feed, but we haven't seen any damage, so you're right, on the flowers. They are primarily leaf-feeding beetle.
Okay.
And that's what this is coming from a group of family that's called Chrysomelidae. And that's basically categorized as leaf-feeding beetles.
Okay.
And that is very abundant group. And there is all different kinds of insects there. Another pest you might be familiar with is Japanese beetles.
Oh, yeah.
Southeast. So that's another leaf-feeding beetle.
Okay. So we kind of categorize those beetles with their feeding source.
Yeah.
If it's a leaf feeding, so this pest specifically belongs to the leaf feeding beetle
but Japanese
category.
beetle can feed on flowers too.
Oh, yeah.
They feed on flowers. But in this case, we haven't seen them attacking any flowers or in particular.
Okay.
They might be feeding it, but we haven't seen it.
So I know another fascinating or interesting fact of the past that I have been learned, that is that some of the pests, they are, I don't know if that's true, but I feel like the male and female, like in the pest world, a lot of times the male is only there to mate, and after that they're gone. Is that right for the red-headed flea beetle as well?
Honestly, I don't know. That's the truth. But if I guess, I would say not so much because males, you're right, they're for mating. That's the main job. But they're definitely going to feed too.
Oh, okay.
And we have seen males feeding and females feeding alike. And I don't know how long they feed in that stage, but definitely males feed.
Okay.
There's no doubt about it.
But so in terms of the population of the male and female, do you have any idea of what is the ratio of the male and female out there in the field? What kind of ratio?
Honestly, I don't know that too. That needs to be researched. So whatever we know at this point is that we are thinking that they are 1:1, but we can't really say for sure.
Okay.
If there is any other endosymbionts, we say some of the gut bacteria that is very specific and driving the females more.
Okay.
We don't know all those things exist in this beetle. We haven't done any work on that area as well. So there is a lot of work needs to be done.
I know, because as we were talking, I was like, hey, what about this? What about that? Because I don't know any of those answers. And I saw that as a researcher, you might know more of those. But then, so that's, I think, one of the fascinating facts of academia, of research, is there's always so much unknown. I guess that's the security of our job, right?
That's right.
So for for the red-headed flea beetle, so basically both male and female are feeding the plant. But how many eggs do you know matured female will lay each time?
That's a very good question. Again, I don't have an answer to it.
Right, I'm asking all those research questions so that we need to do work on that and to answer those questions.
There are many basic questions we need to know about this pest that we don't know. We can guess it, but I think the guessing may not be right here. So that's why I'm not giving a number to it. But we don't know how many eggs they lay, how long the adults live. We don't know how many times they mate, when they mate. We don't know a lot of basic biology of this pest yet. Like I said, I walked into this pest, studying this insect 8 years ago because the growers were having problems with that. So my goal at that point, and still, is to try to manage it. And we didn't do much work in understanding their biology a lot. But we are interested to do that. Hopefully, with time, we'll learn more about this.
Because those are very fundamental information about this pest. And I would think that from the research perspective, if we know those answers, it might provide us with more information for us to better control them, because we can interfere on their life cycle at different stage and say what would be the best time to interfere in that, and then make the best management tool for that, right?
That's right.
So for the red-headed flea beetles, when would you think it'll be for the growers? When would be their peak season that they will cause the most damage for the plant? And is that in the summer, or what's the thought in there?
That's good. Good question. So we, when we started this about studying this pest, these were our basic questions. When they are there, what is that? What stage is present in what time, and how long they will remain like that, and is that a problem throughout the year? So my graduate student basically addressing all those things. So he was trying to understand the phenology of this insect. So how many generations are there in this year? So we are just asking one question at a time. And this is one question we asked. Try to understand how many generations. Based on his work, I think we have 4 generations, and that's basically that we understand. And what was your other question? Yeah.
And we do, there's a word that called scouting for people who goes out and looking for pests and then take actions to prevent it from getting worse.
Right. So we start, in our case, in Georgia, and mostly maybe a little variation in going north, we start seeing their adults coming in May. So in first to second week of May, we start seeing them. And once the growers at this point, they all use visual means to see whether the beetles are out or active feeding. We don't have a trap, anything like that. Like I said, there are many areas that we need to study about this pest. We don't have a lot of access to all those things. But still, the method right now is look for adults. And if you see any damage, that's kind of indication that you need to make an application. And in our case, it is about first to second week of May that we see the first peak emergence of adults happens. After that, it will stay about a month or so like that as an adult activity. And with time, you will see adult activity go down. And in that time, basically all laid eggs and is larvae going on at that time. And we have a gap in June. And after that, in July, they will see a second generation coming in. And after that, we'll see a peak. Then after that, there is so much, depending on who came early and who came late in May, there's an egg laying process and a differentiation in egg laying and development happens in the containers. In that way, there eventually with the second generation, you start seeing an overlap in generation. So then we can't really pinpoint, okay, this is a third or second. We can't really tell because it becomes so overlapping at that point. So third and fourth is always like that. It's very difficult for us to. Another aspect that we are finding is the host plays a big role. Some hosts support them at development very quickly and others are not. And we see that across the board. And when we think about management, that's why this is a very difficult pest to manage. It's not like we developed a growing degree day model and say how much heat they accumulate, and we say this is the time to apply. It is not as easy as that, because the hosts, and when they come in the nurseries, all plays a big role in what eventually happens in that nursery house that kind of falls out in the rest of the season. So it is complicated because of that, and that's why this is a very difficult pest to.
Yeah, because I was thinking about like if the first or if the scouting starts in May, and people will start to see the damage, and then that's when they need to start spray or take management tools to manage it. Speaking of that, I know that you guys have done a lot of work in trying to manage this pest. Are there any effective method that you will give the grower or whoever who wants to manage this pest, and give the outline of how to manage it effectively with your knowledge?
That's right. So going back to what you just said about how complicated it is. It is complicated because it's not just a distinct generation.
Yeah.
We are also talking about space in the nursery and how the plants are kind of spatially distributed.
Yeah.
And their ability to feed on multiple hosts. And that basically complicates how we're going to manage it. So we have taken multiple approaches to really tackle it. So we try to focus on adults first, because that's more economically important stage of the pest, and that's what we targeted first. So we did several studies to understand and screen the few important ones that growers can use. For example, if a grower is using neonicotinoid insecticide spray, that is a very good insecticide that can be used for managing this pest. Other insecticides like Sarisa is a cyclininiprole, and that product. Expire is another one. So there are many other insecticides that we found, like a handful of insecticides that can be used. There is a new one that is planazoline that's coming just on the pipeline.
Okay.
So I hope it will be coming, and it's also very effective products. So there are some tools, not a lot.
Yeah.
There is some tools that they can use as a foliar spray. We are also interested in tackling the larvae. So we went with drench applications.
Yeah.
And there is a handful of insecticides that we can use. Again, some of them are also labeled to use as a foliar. So that is a challenge here. So when you come up with managing this pest, needs to be a multi-pronged approach. It is not like one foliar spray here on this crop will take care of it.
Yeah, because it does, both the larvae and adults can cause damage to the plant.
Not necessarily the larval stage causing the damage, but the adults can move to other plants and still stay there and complete a generation there. And you might be not having any problem in the crop that you sprayed, but they are going to come back.
Oh, yeah.
So it should be a kind of a strategy where we are doing both the application methods in such a way that we can suppress the population. And that's kind of an area that I'm trying to develop a program, or trying to come up with a strategy. Right now, I'm not there yet, because I need to know how they're moving, how they are behaving with different hosts, and all those things still need to be known. But right now, what really works is a drench application, or a granule application of neonicotinoid insecticide. If the nursery is willing to do that, if they can do that early in the year, in the season, like sometime in April. If they can make that application, it will have insecticide residues on the plant.
Okay.
In the plant, so adults can be stopped. Not necessarily the larvae here. We can stop the adults from feeding. And we know that it can go multiple months like that. Protection.
Okay.
It is good enough that if growers can strategize that according to their marketing window, because there is a spring window, early summer window, and there is a gap there, then there's another window starts. So growers need to strategize their use of insecticides or management strategies based on their selling points at the window where they're going to sell all the crops.
Yeah, kind of following up on what you just said, there's still a lot of unknown about this pest, and then because of the complication of the pest and the relationship between the pest and the plant itself. What is your next step of the pest, of managing the pest, let's put it that way?
Yeah. So we want to know, like I just said, I really need to know how they behave in the nurseries. One thing my other graduate student is working on is when we spray a block of plants, like hydrangea, a block of plants, you can get the protection from this beetle to that block. But eventually what happens is that we are pushing them to other plants and where they normally won't go.
Yeah.
And we are trying to understand what is their behavior. Are they going to go there or lay eggs there or not? Those kind of things we are going. So how they move within the nursery with the complication that the host itself and also how they manage it currently. Because they can't afford to spray the entire nursery same time.
No.
We cannot do that.
It's very expensive. For those who doesn't know, like chemicals or insecticides are super expensive.
And labor.
Yeah.
Is also
yeah.
So that is one area that we want to figure out. Okay, what is the best way to go? What host they prefer as adults, and also for egg laying. That is another area that we are working on. So my graduate students are also working on that. So we are basically working on different projects and different pieces. And the idea is that maybe in a couple of years, we might be able to pull everything together and make a sense what's going on.
Okay.
Because we really don't know what is really, really going on right now. Because as an adult, they can feed on many things. As a laying eggs, what they prefer.
Yeah.
So we need to know that because X and Y hosts, probably they are not feeding.
Yeah.
But maybe they're using as a host to lay eggs.
Yeah.
We don't know that part. So there are a lot of questions still there we need to understand before we come up with and say something comprehensive or something like a recommendation.
Yeah, I kind of love my job with ornamentals, but also it's a pain as well because things can get very complicated in terms with ornamental and then the ornamental relationship with or the crop relationship with like the microbes and the pests and then pollinators and all other things that goes within the whole world of the crop. So now let's move back to the main focus here. If you do have an extension appointment, so if a young grower coming to you and say, "Hey, Dr. Joseph, I want to set myself up for long-term success," what kind of information or what kind of suggestions you would have for them?
That's a good question. So let me talk in the context of red hair flea beetle contest. One thing that they can do is when they move plants into the nursery, they might be buying a plant material or whatever. Make sure you just isolate it somehow.
Oh, yeah.
From your
quarantine.
Quarantine, that's the thing.
Yeah.
So, we worked with this flea beetle and we tried to do some kind of fencing where we had an overhang inside so that the beetles cannot move from that area. So bring the plants, when you bring new plants into the nursery, watch for the plants really carefully. Don't unleash it into your main area because we want to watch it. And if you can give if you see any insects there, that's basically the time to watch that. Any activity, monitor them for any insect activity. If you see something there, you might need to make an application and make sure that you give some precautionary treatments before you move into or put those plants into other areas. It's very easy to say because it is often challenging for...
Because in terms of like doing that for growers and they are sacrificing their space and labor to have a separate space for that plant.
Yes.
And that's money and effort in there. So for anyone who's out there, go to the big store and grab something. You think that's just a plant from the Home Depot or Walmart. It's not just that. There's a lot of going on behind the scene where the plant is growing and they have all those interactions with the pests and they have to combat the whole challenges to be able to come to your door.
Right.
So just in general, just be appreciate with the plant that you're buying and then for that.
Right.
So with that, are there any other last comments that you want to leave for our audience?
That's basically it. Just keep following us
Yeah.
Years come, probably we'll have more research coming in. So once we get all those work done and published, we might have some recommendations and guidelines for growers to use.
And don't worry, I'll have Dr. Shimat Joseph coming back to the show in the future and give us updates. So with that in mind, if people want to keep a finger on the pulse of what you are doing, following along with the work, where do you recommend to go and to look out for and find out more?
That's great. So within University of Georgia, we have a department website. And if you go there, you should see all the faculty members listed.
Yeah.
And my name is also listed in there.
Yeah.
So if you go there and click my name there should be a page opening up. That kind of lists the publications that comes out from my lab. Like I said, my work is more applied and more practical as much as possible, that I always try to be like that. So that is useful to people right away. And we also have in that website, you will see all the list of publications. And we also have a blog. And I would just say, please sign up for the blog. And we write any new things coming up, any new findings that we find on different insects. We write blogs. And if you sign up and subscribe in that, there is small 3 boxes there with your email address and your name. You should get an email with any new updates. And that's one way to get in touch.
Thank you so much. Thank you, Dr. Shimat Joseph, for taking time out with from his busy schedule and talk with us today. So as always, I'll try to put the show notes in the website, and then you can find more about his topic and his work. Make sure you hit the subscribe button and consider giving a review for the podcast and donating to the podcast to support the show. Thank you for listening. Until next time, stay healthy and go plants. Adios. Conversation like this only happen when you support the show. For more information and find ways to support us, please go to bnbpod.com, bnbpod.com. If you like what you are hearing, spread the word and share this podcast with the people you love. Make sure you hit that subscription button and give a review for the podcast. And as always, go check out the show notes to learn more about this topic and other topics we featured on the show at bnbpod.com. Thank you for listening. Till the next time, stay healthy and go plants.